Hi, my name is Caroline, and for my final project, I decided to focus on glacial recession in Glacier National Park. I chose this topic because I have had an interest in the Arctic and glaciers ever since I had the opportunity to study abroad in Finland. While there, I was living in and taking classes about the Arctic. My classes talked a lot about Arctic ice melt and the impact it will have on the world. Being intrigued with the Arctic and ice melt, I decided to focus my final project on the impact glaciers are experiencing from climate change here in the United States. I also have a strong interest in national parks, as they are one of the ways that the United States works to preserve natural areas. This map here represents all the national parks in the United States. And with my combined interest in Arctic and glaciers and national parks, I chose to look at glaciers within Glacier National Park. This park is the 5th largest national park in the lower 48 states and has the 2nd highest concentration of glaciers in the lower 48. Glaciers serve a variety of roles, not only to the habitat they exist in, but also to the planet as a whole. They are important indicators of global warming and climate change, and they not only store water in the frozen form, but they are also a supply of fresh water as they melt. Overall, the Earth's glaciers contain 75% of the fresh water on the planet. The surface of glaciers is also a host to a variety of microbial activity. There was a recent study done by the Bristol Glaciology Center where they looked at the crinoconite holes on the surface of glaciers. These are small water-filled depressions that form on the surface of glaciers and are colonized by a diverse range of microorganisms, including viruses, bacteria, and algae. The study found that on a global basis, these crinoconite holes have the potential to fix as much as 64 gigagrams of carbon per year. Starting off with some background information, Glacier National Park was established in 1910 and was the 10th national park in the United States. When the park was first established, there were around 80 named glaciers, and by 1966, that number had dropped to 35. In recent years, the status of glaciers has continued to change, and in 2005, there were 32 named glaciers remaining. The most recent satellite imagery from 2015 showed only 26 named glaciers left in the park. As climate change has continued to progress, some of those 26 glaciers may no longer be large enough to meet the glacial size criteria today. In addition to the roughly 24 named glaciers that remain and are actively monitored by the USGS, the park also hosts several unnamed glaciers, around a dozen rock glaciers, and many snowfields. For my final project, I chose to focus on 2 glaciers, Chaney Glacier and Ipasha Glacier, and look at how the glaciers and area around them has changed in recent decades. Both of these glaciers have experienced a great deal of recession, but they are still large enough to meet the glacial size criteria. The research question I decided to focus on is, how has climate change impacted Chaney Glacier and Ipasha Glacier from the mid-1960s until present day? This map represents the glacial extent from 1966 to 2015 for the 2 glaciers. To assess my research question, I used a variety of data gathered from the USGS and National Park Service to look at Glacier National Park as a whole, and specifically my 2 glaciers of interest. The USGS has been actively tracking the named glaciers within the park since 1966. This map uses USGS data to represent the glacial extent in 1966, 1998, 2005, and 2015. As you can see, there's been a great deal of recession between 1966, which is the green layer, and 2015, which is the pink layer. Overall, since the Little Ice Age, these 2 glaciers have both experienced over a 65% decrease in size. But when looking at the more recent years, between 1966 and 2015, Chaney Glacier and Ipasha Glacier both experienced around a 40.6% decrease in size over the 49-year period. Accurate and clear spatial data for earlier years is hard to come by, if almost non-existent. So when using other data sources to look at glacial change, I examined the more recent years. When comparing Landsat data, I used Landsat 5 imagery from October of 1998 and Landsat 8 imagery from October of 2020. I changed the band combinations for both images so that the glaciers would appear as a blue, the vegetation as a green, and the bare earth as a light brown or white. I used the USGS glacial outlines to help define the extent of the glaciers for those years. Between the two images, you can see not only a slight change in the size of the glaciers, but also a change in the vegetation and amount of bare ground on the ridgelines. We can see that as the climate changes, the glaciers are shrinking and species of vegetation are expanding their regions. To further assess the vegetative change around the glaciers, I conducted a normalized difference vegetation index analysis to compare how the vegetation has changed over the 22-year time period. When comparing the two maps, you can see an increase in the vegetative growth up some of the mountains, and you can see that the darker orange and red areas are becoming a lighter yellow, showing that the mountaintop vegetation is starting to change as well. The area as a whole experienced some level of change in vegetative growth, but the red regions on this map represent areas that between 1998 and 2020 experienced a drastic positive change in vegetation cover. You can see that a lot of the land cover is occurring along the mountaintops, and there are a few small spots of change around the edges of the glaciers. Through running an unsupervised classification on the Landsat 5 data from 1998 and the Landsat 8 data from 2020, I was able to compare the glacial recession and vegetation progression between those years. My results were thrown off a bit by the shadows from the mountains, and some of the ridgelines in the 2020 data had a similar spectral signature to that of the glaciers, so the size of the glaciers became distorted as well. Even though the classification had some discrepancies, you can still see that there was a change and progression in the vegetation, and using the glacial outlines, you can see that from 1988 to 2020, there was some glacial recession that occurred. To help visualize the glacial change, I found imagery from the Northern Rocky Mountain Science Center, which shows how Chaney Glacier has changed between 1911 and 2005. The two pictures on the top are the terminus, and the two pictures on the bottom are the notch. These images clearly show that Chaney Glacier has undergone a drastic change since the park was first established. Glacial recession is one of the ways we can physically see the impact that climate change is having on the planet. Glaciers naturally cycle through periods of advance and retreat, but in the past few decades, the glaciers in Glacier National Park have faced an accelerated rate of recession. This is in part due to the increase and acceleration of climate change. Looking at climate data such as temperature change, we can see the correlation between the rising global surface temperature and the receding glaciers. When looking at the NOAA surface temperature data, we can see that from the 1960s to 2015, the temperature increased around 1 degree Celsius, and in that same time period, we saw a 40% decrease in the size of Chaney and Ipasha glaciers. Overall, Chaney Glacier and Ipasha Glacier have experienced just over a 40% decrease in size since the 1960s. Through comparing this glacial recession with climate data such as surface temperature change, we were able to see that over the same time period, the Earth as a whole went through a period of warming, and in turn we saw a recession in the size of many glaciers. Moving forward with this project, I would like to start looking at the park as a whole. I would like to try and take a look into the future and estimate when the glaciers might completely recede. In 2003, it was predicted that all the glaciers in Glacier National Park would be gone by 2020. As 2020 has come and gone, and several of the glaciers are still present, I would like to look at past climate data and glacial recession rates to predict how much longer these glaciers in Glacier National Park could be with us. I would also like to look at the ecological impacts the park could face from losing the glaciers, such as how the hydrography of the park could be impacted and what species would be threatened from the loss. I'm also curious about the impact that losing the glaciers could have on ecotourism. One of the main reasons people come to Glacier National Park is to see the glaciers, and if they are no longer present, will there still be the same interest in visiting the park? There are many different paths I could follow moving forward with this project, and I hope to pursue some of them in future courses. Thanks for listening.